Hi folks, Gary Reed here with Addy Machinery. Thank you very much for tuning in to what is effectively the second video in our series dedicated to Markforged 3D printers. But first, a bit of housekeeping. If you do have any questions about any of the information that's presented today, please contact Addy Machinery directly and they will direct you to me. So during our first video, I promised our customers some more content related to the industrial end user, and I very much want to keep that promise. So the topic of today's video will be 3D printed Vise jaws produced on Markforged 3D printers. And you know, I wasn't real sure what to expect when I started working on this project, but so far the results have been very promising. And the ultimate goal as we kind of step through this thing is to actually take some of the soft jaws that we've printed and use them on a machine to actually machine some parts. And as we go through that process, I'll certainly be sharing the data that I obtain in case there are others out there who are interested in potentially doing the very same thing. So in the next segment of the video, please stay tuned. I'm going to be showing you a couple of examples of printed Vise jaws that I produced, and we're going to be doing some clamping and torque tests. Thank you.
And now for the legal stuff.
Hi folks, welcome back. So we've got the camera set up where hopefully everybody can see what's going on here, and this is the first Vise Jaw example that I wanted to show everyone. And this Vise Jaw here is modeled after the standard Vise Jaw that came with the vise, and the vise we're using here today is a SOA GS890 6-inch vise. It's similar in design to a current DX6, but it is not identical. Nice, heavy, well-made vise. And the dimensions that we're looking at on here for the soft jaw, for the Vise Jaw, the overall depth here, 710 thousandths of an inch. We've got a counterbore on here of 510 thousandths of an inch, and that only leaves us a wall basically from the bottom of the counterbore to the back of the jaw here of 200 thousandths. So that works out just fine for the standard jaw using the 1/2 13 fasteners. You know, metal against metal. That works just fine. So the first issue that I had, the part printed just fine, but the issue that I had, and this is reinforced as well. I'll take you over to the computer in a second and show you how I did the reinforcing. When I went to install my fastener, my first fastener, and torque it, that's when I ran into some issues there. I was only able to put about 20 to 25 foot-pounds of torque on this socket head cap screw, this 1/2 13 socket head cap screw. I felt like putting any more torque than that on there. I don't know if you can see this in the shot or not, but the thermoplastic actually started to yield a little bit, and that's even with the reinforcement being added into the part. But I addressed this issue in the other design that I'm going to show you here in a second. So I'm going to go ahead and install the jaw, and I'm going to do a test. That's really what I wanted to show you, because I think that's going to be the thing that gets the most attention and is most impressive. Certainly what impressed me. The design of the jaw here is nice. Designing and manufacturing these with a 3D printer is very nice, because you can do some things quite easily that you just can't do as easily with a jaw that you have to machine. So you can see this is a square part here, 1 inch square, transitions to a 3/4 inch round diameter up here, and I can nest these parts quite easily into the vise jaw. And now that I've got those nested in there, I mean, these can't come out. These fit nice and tight. The parts can't go up, they can't go down after they've been clamped. They're not going to be able to twist side to side, and I don't have to use any parallels on there either, and that's nice. Another nice feature that you can build in here, and this just kind of happened to work out on this, we've got a built-in poker yoke into this fixture in here. And so what is a poker yoke? Well, that's a Japanese term that basically means to make something foolproof. This is a nice tight fit on there. Having trouble getting it in and out. But you can see here, there's only one way I'm going to be able to load this component. I can't load it this way. I can't load it this way. I can't use the wrong type of raw material. So from a setup standpoint, that makes it pretty nice. And then another nice thing about this is, you're not tying up your machining center doing something that's not making you money. You don't have your expensive operator sitting there, making work holding for the next job. This jaw costs $23 in material to produce, and print time was 17 hours. I know everybody's saying, wow, 17 hours, that's a really long time. But if you think about it, you can set the printer up and you can walk away from it. You can be doing something else. It's not like somebody standing there and having to watch over the thing for those 17 hours. So while your machine's out there making chips and making you money, you can have your 3D printer set up, doing work holding for your next project. So that is quite nice. So we're going to go right into the clamping test here. Well, I have 2 of those wrenches here. Run the screw up. We're going to go to our torque wrench. I've got this set on 50 foot-pounds. I hope that shows up in the video there. Right there is 50 foot-pounds. Hit that 2 or 3 times just to make sure it torques and is not continuing to turn. And anybody that's watching this, they're thinking, well, okay, Gary, that looks great, but 50 foot-pounds, that's not a lot of torque. Well, when you consult the folks at SOA, 50 foot-pounds of input torque on this drive screw right here equates to just over 4,000 pounds of clamping force. And I'll tell you right now, you're not going to be able to move these parts. There's no way these parts are going to come out of there. And I think that this is something that would be rigid enough to where if you were clamping metal parts in here, I think you could easily come in here and do drilling and some light milling operations and everything on the top of this part. Of course, these are not very robust parts, but I think that's in there very nicely. And you can see here that the jaws, they've not yielded. We were able to torque them up. If the jaws were crushing in some way, or the parts even, that was the thing that really surprised me. The parts themselves, those are not reinforced parts. Those are just, onyx only parts that I produced on the printer. And you can see here, I've clamped them a bunch of times. The fit is so darn tight. Wiggle them to get them in and out of here. Parts are not crushed. Neither is the jaw. I'm going to go ahead and take the jaw out here now too so you can see that. Put this back a little bit. So you can see the jaw survived. This has been printed for several weeks now, and it hasn't warped or deformed, still nice and flat. That's really impressive, though. The doggone parts, those are not reinforced parts, and I've clamped them a bunch of times, and they're still holding right together. They didn't crush, so that's interesting. So this is example one, and hope you got some benefit out of this. And let's move on to example two.